Okay, so I thought I'd make a slightly different type of video here. So normally with the microcontroller project sort of videos, it's like, okay, here's a wiring diagram, here's some code, that's how this goes together. And it might seem really, really confusing to people trying to pick up, learn microcontroller stuff because all they see is the finished product and not how necessarily how we got there. So I wanted to make a quick video about some troubleshooting steps so you can see the process, at least get an idea of the process for coming up with those solutions instead of just seeing the final product. So this is an upcoming project I have. Where this comes from is I teach software development courses, which means the examples in the classroom are text, right? And just the leading students through examples of writing program, which means writing text, and I project that on the board. But it's hard to read text projected onto a board from the other side of the classroom. So along with that, I also stream the code, stream it across the internet. That way, the students can pull it up there on their local monitor as well, and sit in the back room like computer people often like to do. Sit in the back row like computer people often like to do. So the problem that I often encounter is I'm not standing by the mouse. I'll I'll be writing stuff on the board. The code's projected there on the whiteboard. But if I need to do some highlighting or scrolling or something with the mouse, I have to walk across the classroom to where the computer's at and use the mouse there, then walk back over to the board. So I thought, well, it would be really nice to have like mouse features on a watch thing. That way I have my mouse button right here on maybe I should say a bracelet, because it's not really a watch. It's not going to tell time. But the mouse button's something to scroll with and click and move around. It'd be nice to have that right there handy. That way I don't have to continually walk across the classroom. So that's what this project is. Without getting into too many details, so that means the Wi-Fi is occupied. And I'm also using Bluetooth, so I'd like to put it on another signal. So I thought I'd try a walkie-talkie signal, or 4.33 megahertz signal in engineering speak. But in normal English, we'd probably just say a walkie-talkie signal. And started putting this together. Everything's working great. Got my transmitter and the receiver. And once everything's finished, the receiver is going to be transferred from instead of being a microcontroller, I'm going to switch that over to just generate the HID report, a plug-and-play device. So then it's a normal plug-and-use mouse. Once the chip thinks it's a HID device instead of an Atmega 328P, but that's an easy later step. Everything was working great though. Sending the signals, receiving the signals, so I can left click and right click, move the joystick around to navigate, and I think all of this will fit nicely in a small space on the wrist. Middle click works, but then scrolling was giving me a bit of trouble. I used a regular rotary encoder to try to get the scroll wheel, and that was giving me a bit of trouble. So instead of showing the final solution, I thought I'd show the steps I went through to figure out what to do on that. Because obviously I went and looked at some stuff, and there were a couple people tried to use lookup tables on an Arduino. And well, I tried that. It didn't fix my problem. Some other people put some if-else blocks right in the loop. I was still having the same problem. It wasn't always registering, and sometimes it would go back a little. It wasn't working exactly like I wanted it to, especially scrolling fast, which is something that's going to happen if the example I'm scrolling through is a lot of computer code, right? You might scroll back and forth. The functions you need to look at might be 50, 60 lines away from each other, which means very fast scrolling, and it was giving me a problem. So I wanted to make a video walking through the steps I went to reach a solution. And then we'll look at the final code I found that works every time on an Arduino or other microcontrollers for the Rotary Encoders. So when the software solutions weren't working, I thought, well, maybe it's a hardware problem. So I went to look, considered how a rotary encoder works. So there's a gear in there. I'll just draw a couple pieces of it. A very rough gear. Obviously, it's going to go all the way around. And we have the teeth sticking out and gaps between the teeth. And then we have two signals. And we could either turn this thing clockwise or counterclockwise. So if we turn it clockwise, well, then this is going to come around. This edge will pass here, and this wire will be in front of the gap first. So if this wire, when this wire changes, this comes over, and then the edge is right here. So when this one changes, this one is the opposite, is still high. So if it's high while it's touching the gear, this one drops low, and this one's still high. Okay, so moving clockwise, if we watch this one, I'll say watch this line and check this line. That gives us a quick if-else to know what's going on. Then we don't need the lookup tables or anything. So we're going to watch this signal, and when it changes, we look at what the other one is. So if this one changes first, the other one will, and the other one is different, because that would continue. As it continues on around, this pin's going to hit the next gear first, while the other one's in the gap. So they're different if we're going clockwise. But if we go counterclockwise, then we'll watch this edge. It'll move over here. It'll pass this. It'll pass the pin we're checking. And then the pin we're watching changes. So if the pin we're watching changes, and this one's the same, then that means we move counterclockwise. So that's our two checks to tell whether the rotary encoder was turned clockwise or counterclockwise. We watch one of the pins, and whenever it changes, we check the other one. So if they're different, then that means we move clockwise. And if they're the same, that means we move counterclockwise, which is something I'd already tried in the software solution. Didn't help, so I thought I'd take the hardware stuff a step further. So then to check my understanding of this, I built this circuit. I have the rotary encoder, the ran power and ground to that, and the two signals here are labeled clock and data. And I had to pick which one to watch and which one to check, so I'm watching the clock signal and checking the data signal. So over here we have an AND gate and an XOR gate. That's what those chips are. So when this turns, first off it looks at the XOR. So this first XOR gate will see that they're no longer the same, because in the resting position, whether above the gear or between the gear, so that's our little clicks we can feel when we turn it. The rest positions, they're going to be the same. So first thing I did is bring it to an XOR gate, exclusive OR, to tell if it turned or not. And then if it turned, then the output from that XOR goes to both an AND gate and another XOR gate. And the XOR comes over here and lights up the green light to indicate it turned clockwise, that they were different whenever it happened. And the AND gate comes to the red LED to indicate it turned counterclockwise, that they were the same whenever that change occurred. Whenever the clock signal changed, the clock line changed. If the AND gate triggers, that means it turned counterclockwise because the data line is the same as the clock. And when the clock line triggers, if the XOR gate triggers, that means the clock and data are in different states, then it should be turning clockwise. And then there's another part over here, which I will get to in just a moment once we see this. So if I turn this clockwise, very slowly, we'll see they both light up, and then the one I was expecting flashed right at the end. That kind of gave me the first hint of what was going wrong with the software. Both signals went high. It wasn't just that one there. They both went high. Well, what happens if we try counterclockwise? So I'll turn it very slowly. That one lights up. And then they both flash at the end. So they both clockwise. It wasn't quite what I expected. They both come on, and then the one I expected flashes at the end. Going counterclockwise, that one comes on, and then what I expected happens at the very end. So that's what this other part is. Since the expected results were only happening at a brief flash there at the end, which, and I forgot to mention before switching the circuit, you may have noticed that in the resting position both LEDs were off and it was only flashing when changing, which is kind of what we want with the rotary encoder. But the expected results only happened as a brief flash at the end. So to hold that, I brought in a NOR gate to build a simple SR latch. Nothing too fancy, 2 NOR gates wired together, inputs, and the outputs lead to the input of the other. And you can look up how to build an SR latch. No fancy enables or anything like that, just the most basic one. So that it'll flash a couple, we'll get those different changes, but then that final flash is the only one that'll stay. So if I turn this slowly clockwise, you'll see that the green light latches on and stays. So that final flash is all that matters, but turning it slowly clockwise, I'm going clockwise, so the other one flashes, but then in the end, after the turn, the clockwise LED indicator is on. And same thing if I go counterclockwise. There's some flashing, so I start to turn, the green LED comes on, but in the end, once it's latched, the counterclockwise latch comes on. So after putting that hardware together and running some tests, I was able to confirm that yes, it's just that final flash, and that was the problem I was hitting in the software. That I was just checking along the way and at different points and wasn't being too precise with where I was checking. And obviously you can see even here with in the final result where it's latching and it's storing that final result, the other one flashes along the way. So that's probably the most important part in the rotary encoder, to get that right on, and that is that it has to be checking at exactly the right time. We can't just check this state anywhere. We have to check that final flash. We can only check that final flash right before it settles into the next notch. Right? When we start to turn it, it feels a little loose, and then the resting position, then it kind of clicks into the resting position. And at that point, there's a final flash of a signal, and that's what we need to check. We don't need to check the whole thing. We just need to check that final flash of a signal. So that led to the final solution of what to do to get this to work. We just need that final flash, which means it needs to happen on an interrupt, which is easy enough in Arduino. Just make sure that, so here on the transmitter, just have to make sure that both of those pins go to pins where interrupts are available. And without getting into port manipulation, that means pins 2 and 3. Set up the interrupts, and that led, and then did just the if-else thing. So if the clock changes, check the data signal. If they're different, that means it turned clockwise, and if they're the same, that means it turns counterclockwise. So just I set up an interrupt and then checked that same or different thing with a simple if-else block and used that to set a boolean flag, and that led to this working perfectly as expected now. So that's the steps I went through to get the rotary encoder to work with. So if you're used to looking at examples of Arduino stuff and only seeing the final product, you miss some of that trial and error stuff. There was some other steps that obviously didn't make it into this video of sitting here for a while with different configurations, turning this, trying to slowly and fast at different speeds, and just carefully examining exactly what happened until I figured out exactly what needed to happen to come up with the correct software solution. So now I'm ready to draw up this design and order a flexible PCB that will wrap nicely on my wrist, which the camera's too close here. That will wrap nicely on my wrist, and then I'll have a little joystick, a left click, a right click, and a scroll. And so that's the problem solving steps to get to a solution for these. I just wanted to make a video about that because we always see short, brief videos just showing the final result and not necessarily teaching people how to get to those final results. So thought I'd make a video about that. Hope that was helpful to some people.